Get ready for one of the best light shows of the year. The Geminids are coming and they are bringing up to 150 shooting stars per hour. But here is the twist. This dazzling meteor shower is not born from a comet like all the rest, but from a mysterious rock comet asteroid, something scientists never expected. So what makes the Geminids break all the rules, and how did we discover their bizarre origin? Every December, Earth's path carries us through a vast stream of cosmic debris left behind in space. These tiny fragments, most no bigger than pebbles or grains of sand, travel alongside an ancient orbit. As our planet plows through this invisible trail, each particle slams into the upper atmosphere at about 35 kilometers per second, fast enough to vaporize in a burst of heat and light. That's what creates the streaks we call meteors. The process is reliable. Earth crosses this same debris lane at nearly the same time each year, making the Geminids one of the most dependable meteor showers in the sky. Unlike a random event, this is a scheduled encounter set by the mechanics of our orbit and the persistent trail left by a parent object. The result is a shower of shooting stars that can be counted on to return year after year, lighting up December nights with their fiery display. Each Geminid meteor seems to leap from a single spot in the sky, a point tucked near the twin stars Castor and Pollux in the constellation Gemini. This spot is known as the radiant. It is the place where, if you traced every meteor's glowing trail backward, their paths would all converge. For sky watchers, Gemini climbs high in the east by late evening each December, making it easy to find the source of the show. The Geminids first drew attention in the mid-1800s when astronomers noticed a new flurry of meteors streaming from Gemini's direction. Over time, the shower's intensity only grew, outshining even the famous Perseids in both number and brightness. Today, the Geminids stand out as the most reliable and brilliant meteor display of the year. They're radiant, a beacon for anyone eager to catch a shooting star on a cold December night. In 1983, astronomers using the infrared astronomical satellite discovered an object hurtling through the inner solar system called 3200 Phaethon. Unlike the icy comets that usually spawn meteor showers, Phaethon looked like a rocky asteroid with no visible tail or coma. But its orbit matched the Geminid stream almost perfectly, tracing the same elongated path around the sun. This raised a puzzle. How could a rocky body supply enough dust to fuel one of the most powerful meteor showers on Earth? The answer began to take shape through spacecraft observations. NASA's stereo mission watched Phaethon as it swung close to the sun and caught a faint brightening along with a wisp of dust trailing behind. Each time Phaethon neared perihelion, it seemed to shed a thin veil of rocky particles, not through melting ice, but by cracking and crumbling under intense solar heat. As planetary scientist David Jewett put it, Phaethon is a rock comet, an asteroid that behaves in some ways like a comet when it gets close to the sun. This discovery turned the Geminids into a cosmic oddity, a meteor shower born from a rocky parent, not an icy wanderer. 3. Competing ideas drive the scientific debate over how the Geminid stream formed. One view holds that Phaethon is a dormant comet, a relic that once shed vast amounts of dust when it was still icy and active. In this scenario, the Geminid meteors are leftovers from a time when Phaethon resembled a classic comet, with its activity now faded to near invisibility. The second explanation centers on the rock comet hypothesis. Here, Phaethon's close brush with the sun heats its surface to 700 degrees Celsius, causing its rocky crust to crack and crumble. Each perihelion passage releases a thin veil of dust, replenishing the stream not by melting ice, but by thermal breakdown of stone. Yet spacecraft data show this ongoing activity is too weak to account for the Geminid stream's size. A third model suggests a catastrophic breakup, a violent collision or internal disruption 1,000 to 2,000 years ago that blasted a huge volume of rock into space. This single event would have released enough material to create the dense, young stream we see today. Most recent evidence points to this sudden energetic origin, with Phaethon's present-day dust production playing only a minor role. On the night of December 13th into the 14th, 2025, the Geminids are forecast to deliver up to 120 meteors per hour under dark skies. Bill Cook from NASA's Meteoroid Environment Office calls this shower one of the year's most reliable, with bright, steady activity that rarely disappoints. A thin, waning crescent moon won't rise until around 2 a.m., leaving several prime hours of darkness for meteor watching. Expect Geminid meteors to stand out as yellow-white streaks, often brighter and slower than those from other showers. Many leave persistent glowing trails, and fireballs, exceptionally bright meteors, are common sights during the peak. For the best Geminid experience, pick a night between December 4th and 17th. The greatest show is expected after midnight on the night of December 13th to 14th. Find the darkest spot you can, such as a park, a field, or a backyard away from bright lights. Robert Lunsford recommends letting your eyes adjust for 20 to 30 minutes and leaving your phone in your pocket. Local astronomy clubs often host group watch nights, so check for events nearby. Bring warm layers and a reclining chair for comfort. Every December, 3200 Phaethon reminds us the universe still holds surprises. As science searches for answers, the night sky offers wonder, free for anyone willing to look up. See you outside.